Here in Cork County Council's Water Quality Laboratory, we test drinking water, surface waters like rivers and lakes, and bathing waters all the time to make sure that they're safe for people to drink and to swim in and enjoy. One of the things that we regularly test for is pH, or what's also known as potential hydrogen, although we're not quite sure because the scientist who came up with the term, Søren Sørensen, never actually wrote down why he called it pH, but people generally say pH means potential hydrogen. And that means that there's hydrogen ions floating around in a water or other substance that are ready to react with something. So if there's a large amount of hydrogen ions in a water or orange juice or vinegar or whatever it is, it's got a low pH. Now, that doesn't make a lot of sense, but it's a negative scale. It works backwards. So it's like saying if I've got a volume control on a stereo, if I turn it up to 10, it's really loud, but it's 0 quiet. If I turn it down to 0, then it's 10 on the quiet scale, but 0 on the loud scale. In the middle at 5, it'll be equal on the loud scale and quiet scale. Similarly with pH, if you're at 1 on the pH scale, it means that a substance is really acidic. It's got a lot of hydrogen ions that are really ready to react. If you're at 14 on the pH scale, it means that the amount of hydrogen ions is really, really low, but another ion called hydroxyl is really, really high. At pH 7, right in the middle, the hydrogens and the hydroxyls are perfectly balanced, so it's neutral. You're not going to have a reaction. So the pH scale only talks about the hydrogen. So at 1, the hydrogen is really high. At 14, the hydrogen ion is really low. Now, if something's acid or alkaline, it doesn't mean it's a problem as long as it's in the right place. For example, you've got acid in your stomach that's at about pH 1, really, really acidic, and it helps break down your food and make sure that you get all the nutrients that you need. But plaque bacteria on your teeth, they can generate acid that can cause tooth decay. So it is a problem there. But toothpaste is alkaline, so when you brush your teeth, it neutralizes that acid, which is really good. But for drinking water, we have to make sure that the pH of the water is between 6.5, which is slightly acidic, just below 7, and 9.5, which is alkaline. And if it's within that range, it's perfectly healthy to drink. And it also means that it's not going to cause a problem for our pipes and our plumbing, or washing machines, or dishwashers and things like that. So it's a really important test that we do all the time in the laboratory. But today I'm going to show you how you can do that test at home using a red cabbage. First, we've got to chop up our red cabbage. Now for this bit, you're going to need help from a grown-up. And I mean a grown-up who's going to take their time and be careful. So chop up the red cabbage into chunks. Put the chunks in a liquidizer or food processor. Blitz it all up into nice small pieces. Put the pieces in a bowl and fill with some water and leave it for about an hour. Now the next bit's a bit tricky. We want to get that red cabbage juice into a bottle. We need a funnel. I didn't have one, so I just cut a bottle and used the bottle top instead. Hold the sieve over the funnel and strain it through. You can see why I'm doing this in the sink. Once you've squeezed out all that purple juice, you can put the red cabbage in a composter. Put the top in the bottle and you're ready to go. Don't forget to clean the sink. Now in the laboratory, we have chemicals called pH standards, and we use them to check our equipment and make sure that everything's accurate. These chemicals have the exact pH that we need to check, and they're pH 2, pH 4, pH 7 and pH 10. Now look what happens when we pour in the red cabbage juice. A chemical called anthocyanin in the red cabbage turns a different colour in different pHs. So it's a really useful thing called a pH indicator. In pH 2, it's red. In pH 4, it's purple. In pH 7, or neutral, it's blue. In pH 10, it's green. Now that you've seen what colour the red cabbage indicator will change for acidic and alkaline substances, why not do some experiments at home with some help from a grown-up as your lab assistant? Mix some baking soda with some water. Is it acid or alkaline? Put some Vinegar in a glass. Is it acid or alkaline? Put some toothpaste and mix it with some water and test it. Is it acid or alkaline? How about orange juice, tea, lemon juice, rainwater? How about your tap water? Actually, don't worry about your tap water. That's a job for the laboratory to check. Now, it's fun to test pH by using a red cabbage, but in the laboratory we've got to be sure we get the answer absolutely right. And that's why we use a robotic analyzer that can analyse about 50 samples in a matter of hours. That's once we program it and tell it what to do. Hope you enjoyed that, and the next time somebody asks you what vegetables you like, you can say, "Oh, I love red cabbage."